All right. Hello, CIS C157 students. We're going to review some week 14 content right now to help you all with the programming assignment that you'll be working on this week. This week we are introducing you primarily. This assignment is going to test your ability to work with generators in Python. So far this term, we've written programs that work with lists, dictionaries, classes, and a lot of exceptions, which are important. But again, we're really going to focus on generators here, and I want to take a little bit of time to talk about generators and explain why they're important, because at a glance, you might think that you could do a lot of the requirements in this assignment just with a for loop and not having to yield results with generators, but there is a good reason to use them. So first off, a generator is a function that produces values one at a time on demand, instead of like building a full list or reading a full file into memory. This makes them a really good fit to work with files of unknown size and length. So if you have a file with 10 lines or even honestly tens of thousands of lines, you don't have to use a generator. You should be able to read that file into memory just fine, and there won't be a performance impact. But when you're working with data sets that are millions, hundreds of millions, sometimes billions of lines long, reading those all at once into memory is simply not an option. It'll take prohibitively long, and it will honestly also crash a program in a computer when you try to do that. So when you're dealing with like real world giant data sets, which people have to do all the time in data science, there needs to be a way that we can iterate or read log entries or lines from that file one at a time and process them individually without taking the whole thing into memory at the start. And that is the whole point of generators in Python. And again, even though the log file that you're working with in this week's assignment is not millions of lines long, we're going to operate as if it is, right? Or as if it is unknown to us at the time that we're writing this program. And we want our program to be able to handle files of any size. So we're going to start off in Visual Studio Code here. As always, I'm not going to do your exact programming assignment, but we're going to do something similar enough to where you can take the concepts here and apply them to your individual one. The concept we're going to work on today is like a weather filter. So we have some weather data, and I'll show you this weather data.txt, and it's essentially a log file that's in a similar format to the one you're given that has dates, times, and then different temperature and humidity readings, and some fields here to mark whether or not the temperature on any given day was normal, hot, or cold based on historical data. Okay, so a pretty simple log file here in this format. And our job is going to be to process this log file, and specifically, we want to isolate the number of hot days that showed up in this data set here. So we have that pre-existing weather data.txt file. And now I have a new program, weather filter. All right. So we looked at the data that we have. What we want to do now is start with our generators. Okay. So let's uh, let's start off first with just comment here. So we're going to say generator to read one line at a time. I'm going to turn off this annoying AI autocomplete. Okay. And then we need a separate generator to process one line looking for hot, right? Because that's the kind of key that we're trying to pull out. We want all of the data lines that were hot for a given day, and we can ignore the other ones. And then we're going to write those to our own file here. All right, so the first generator's job is simple, right? We're going to read one line of a file at a time and yield that line back. And then the generator is going to kind of pause while that's being processed. So we'll start by defining a function, and I'll call this one, I don't want to do read line, I'll do read weather line, and it's going to take in a file name as its only argument, the file it's going to read from. And then when we're reading files, it's always good practice to use a try except in case there are errors like the file doesn't exist or we don't have the right permissions. So I'm going to try, and then I'm going to use this with syntax here. So with open, and then we're going to open the file name that was passed in to this function, and we're going to open it in read-only mode because we don't want to edit the data at all. We're just processing it. And we're going to open this as a variable called file. Okay, now this with syntax right here, your textbook actually doesn't highlight this or spend much time on this at all. The with syntax for opening and reading a file here basically handles a lot of the upkeep and house cleaning for you. So if you use with and then you process a file, you don't have to manually close the file when you're done with it. The file will close itself once you exit out of this indented with block here. So that's the modern way to kind of work with files in Python. You almost always want to use with so that you don't have to remember to manually close the file when you're done processing it. There can be a lot of issues and errors that come up if you leave a file handle open and forget to close it. So with solves that. Okay, so we have the file open now. And now what we want to do is we essentially want to process a line. So we're going to do a for loop, and we'll say for line in file. And then we can do yield line dot strip. So we're going to yield or just return one line, and we're going to strip off any trailing new lines or anything like that from the end. And then we'll have to do our accept clause, and we'll accept, we want to do there are a few different errors, like a file exists or file not found. We'll just do a file not found here. So if we accidentally pass in a file name that doesn't exist or it's not found, we'll just print a message saying could not find, and then that file name parameter. All right, just like that. Okay, so we have that working with our generator here. The next thing that we want to do is we want our filter generator. Okay, so we'll call this one filter weather. And this is going to take in lines and a category that we're looking for here. All right, and just same format as the last one. We'll do for line, this time in lines that are being passed in. And then we just need to check whether or not the category is in that line. And so rather than iterating kind of word or character by character, we can just use the syntax like if the category is in the line. So if that word hot, which is what we're going to pass in, but you could pass in any string here. If that string is anywhere in the line, we want to yield that line. And if it's not, we're not going to do anything, and the loop will continue on and just not process that line. Okay, so notice this function doesn't open any files here. It doesn't know or care about where the lines came from. All it knows is that someone is going to hand in a stream of strings and ask it to keep only the ones that contain the category word, that keyword we pass in. All right, and so we're really separating concerns here, right, between our functions like we've talked about before. So each one is handling something discreetly, and there aren't many dependencies between them. So this filter weather function, typo there, filter weather function doesn't care and doesn't need to know about where the data is coming from. It doesn't need to know what the file name is. It's kind of in its own sandboxed environment, just concerned with searching for whatever word we pass in a line and then returning it if it finds it, and that's it. Let's see. Everything else I think is pretty self-explanatory about this. You can also notice here that yield usually replaces where return would go in a function. And so if you're ever kind of trying to figure out where yield should go, figure out where you would normally return a value from a function and then substitute yield in there. And often that will work just fine. So it's pretty familiar logic here. Okay, so now is the interesting part. We have two generator functions, and they are generator functions because they yield instead of returning. Now we want to put those functions to work, and we're going to do that kind of in the main part of our program here. So we'll declare some variables here that have to do with our file names, so we can just pass those in. We don't have to worry about typos. So first, I'm going to create one called input file, And I'm going to set this equal to weather data.txt. Okay, so that's the file we want to process. Then I'm going to have an output file. This is where we're going to write the results because we want to remember, based on your assignment, you want to pull out errors and you want to keep track of how many errors occurred, but you also want to copy over basically each log entry that has an error into it into a separate file. We're going to do the same here with our weather. So I'm going to call my output file hotdays.txt because that's what we're tracking. And then since we have to put in a target category, I'll also just define this as a constant so I don't make a typo. Target category equals, and it's just going to be hot. Now, if I do it lowercase, I'm going to have an issue because if I look back at my data, all of the temperatures are in all caps. And so that matters the way I'm writing my program. So I want to make sure I'm matching the exact format, the casing, everything that I find in my actual data so that it works appropriately. Okay, so those are our constants that aren't going to change that we're going to use here. The next variable that I want to declare up front before I start processing anything is a count of how many hot days there are, since I want to keep track of that. And the best way to do that is to make a variable called count and set it to 0. Okay, it's going to start at 0, and then in our main logic here, every time we find a line that has hot, we're going to increment this count by 1, and at the very end, we will have a total count. Again, you want to do this outside of any loops because we want access to this variable at the end of our program. So scope is important here. We want to declare this kind of at the top of our program near the constants so that we have access to it at the end of our program. All right, now we're going to get to actually opening the output file and performing some logic. So since we're writing everything to a file, we can start that process here as we're using our generators. So we'll start with a with open again, and this time I'm going to open my output file, and then I'm going to open it in write mode because I want to write to this file. And then I will use the as keyword, and I just have to give this file a variable here that we're opening. And so I'll just name it out file. Okay, so with open the output file path in write mode as a variable called out file, this is where we're going to start calling our generators. So we can call all lines equals read weather line, and we're going to pass in our input file. All right, and then we can say hotlines equals, and we want to filter weather with the line or with the all lines that we just took, as well as our target category that we're looking for. Okay, just to match the function signatures that we had above. Now, this should process everything for us here correctly. So we want to do two additional things kind of in this body of this file that we have open right now. Remember, we're going to correctly pull out the right lines, but we have to instruct this open block that we're in to write those lines to the output file. And then we also need to increment the count. Those are the two pieces of logic that we didn't handle in our functions above. So the first thing is, let's write it to the file. So I'm going to say, do a space here, for the individual line in hotlines. Remember, hotlines are the ones we want to write. So for each line we find there, we want to take our file, which is out file that we named up here, and we want to write to that file. So we'll call the write method. And what do we want to write? Well, we want to write the individual line. And then one of the things that you'll learn about write is that it doesn't automatically put a new line character at the end. So if we just write line, it's only going to write one long line. Everything's going to be on the same line. So we want to do a plus, and then we want to use the syntax for a new line character, which is this \n here. Okay, this tells write to write the data in the line and then append a new line character, which will result in a new line. Then the next time the for loop runs, it's starting on a fresh line. Okay, and then the last thing we want to do, since we wrote that line, we want to update our count because we found a hot line, right? So we'll just do count plus equals 1 You could also do count equals count plus 1. Count plus equals 1 is just a shorthand. All right, and that's it. And then notice I don't have to do anything like outfile.close here. The reason I don't have to do an outfile.close when I'm done is because I have everything in this with open block here. And that's just some, what's called like syntactic sugar. It's just a little bit of magic that you can do in Python where I don't have to close the file myself. That's essentially what the with is doing. It's saying here, once you exit this block, this indented part of the cleanup that Python will do for you is close the file. And if it's the last thing that you run, it will also just close the file at the end. Okay, so again, let's just walk through the logic here. So first, I'm going to store like the names of the input, output, and target category and variables so we don't worry about typos. I'm going to set my count to 0 so that I can start counting later on. And then I'm going to open the output file in write mode with the with block. All right, and then the W argument here just specifies the mode that you're interacting with the file. So we have several modes. We look at these, we have plus A for append, we have append binary, we have a lot of different ones. The primary ones you work with are R and W and sometimes A for append, but we're writing to a blank file. Key takeaway though is the W or the write mode overwrites anything that exists in this file. So you only want to use it with new files. If you're working with existing data, you want to use almost always append mode if you want to edit it. And then if you don't want to edit the file, use read mode to protect yourself from accidentally deleting or overwriting data in the file. Okay, but that's the difference between W and A. A will append to the bottom of a file. It won't overwrite it completely. W will completely blank out the file and start from scratch. Okay, now let's look at the next two lines here. So we have all lines, and then we call our first generator function. Okay, so this first one does not actually read the file yet. Calling the generator function above does not run the function body. It just creates a generator object that is ready to start producing values. And this is a key difference in generators, because if you read this function here, you would think, well, it's opening a file and it's iterating through the file line by line and it's yielding a value. So that's the benefit of generators. We can call it on the entire file and it doesn't actually do anything yet. It basically preps the work to be done. Okay? Just creating a generator object that's ready to produce values, but it's not doing it yet. Then we have our next line, our hotlines here. And this one again does not run yet. It just creates a generator object. Okay, the hotlines. The work begins down here, believe it or not. No, like none of our code is being processed yet here. We're just setting up the framework that we need to process things one at a time. Once we get down to 4 line in hotlines here, that's when work is going to start. And it's because we are referencing hotlines, which contains a generator value. And you can see even in my type hinting on the screen here, this little box above, Python is smart enough to know that hotlines is a generator, right? It's not a list of strings. It is a generator at this point because no code has run yet. This can be a tricky concept to wrap your head around. And so that's why I'm reiterating it and going over it kind of over and over again. It'll become more clear the more you work with generators, kind of what those look like. And in fact, to demonstrate this, here's what I'm going to do. Let me comment out this part of the code. And I am going to, after we do these two things, I'm going to print the values of all lines. And then I'm going to print hotlines. And let's just run this and see, right? So if I didn't just explain to you that these were generators, you would think that all lines contains like all of the strings in the file, because that's what the function appears to be doing. It's yielding every single line in the file line by line and just stripping the end of it. And you would think that if we ran or we printed hotlines would only show the strings that have the word hot in it. Okay, so let's see what they actually display. So I'm going to go in my terminal and I will just run Python on weatherfilter.py. And this is what's printed out. In Python, it says it's a generator object pointing to the function readWeatherLine at this address in memory. That's all that this hex is right now. Same thing with hotlines. It says it's a generator object pointing at the filter weather function, and it exists at this place in memory. All right, that's all the data that's in here. No processing has been done yet. These functions have not run yet and done their computation or their work. But I'll go uncomment this now. Okay, and what I'm going to do is I'm going to print each individual line. I'm not going to write yet. And then if I run this now, you're going to see all the hotlines print here, and we still have our two generator objects above. So what's happening here? The way it works is the work begins when we call hotlines. The request walks backwards. So we say for line and hotlines. The program goes, okay, where's hotlines? It jumps up here and it says hotlines is a generator that is pointing to this function. Well, we were just requested a specific piece of data from that generator. So the generator is going to say, I need to do some work now. Let me go to the function that I'm pointing at and go until I see my first yield, and I'm going to stop right there. So this will jump up to filter weather, and it's going to say, okay, what am I doing? For line and lines, if category in line, yield line. Well, it's going to yield the line there. But before that, we have all lines that's being called in hotlines, right? So it's going to say, where is all lines? All lines points to a generator, which points to a function. And we're asking for the value of this now. So this generator is going to go off and say, I'm going to do work and read weather line until I hit yield, and then I'm going to stop until I'm asked again. So then it's going to jump back up into read weather. It'll walk through this. It'll see yield. It'll return one value and stop running. That value will go into all lines. All lines will pass it here. Now filter weather has the correct both arguments. Filter weather will just read through lines until it finds the first hotline. It'll return that line. That line will go into hotlines, which will pass down here. And then this logic goes. The next time the for loop iterates, on our next iteration, it repeats that whole process, working in reverse, kind of back up the chain there. Okay, so the for loop receives that line and only that line and writes it to the output file, right? It's not receiving all of the lines here. The whole pipeline operates one line at a time, right? So at no point in this program, while it's running, is the entire file in memory. At most, there will be one line out of weather data. Just one of these lines is going to be in memory, and the program's not even going to know about the existence of the other lines. And again, that is the key use. That's the reason we use generators. If this file were billions of lines long, which you legitimately find in some data sets that you work on in the real world, it would, again, take forever and or crash your computer if you tried to read that whole thing into memory. And so generators let us work with data sets of immense size without having to worry about any of that stuff, about how much memory your computer has or how fast you want a program to run. All right, hopefully that made some sense there and helped clear up kind of how this program is running and what it's doing. I'm going to get rid of these print statements. And then we want to just print a summary at the end of this, right? Since we're tracking this data. So let's just do a print. I'll do an F string and I'll say saved count hot days. Wrote hot days to output file. All right, just some summary of what happened in the program. The main thing is we want to make sure we have the count there. Okay, so I'm going to delete hotdays.txt that ran last time, and we'll run this program again and see if it's accurate. So I'm going to run it. Let me get rid of my print because that was just for demonstrations. I'll run it again. All right, and all we see is saved 26 hot days, wrote hot days to hotdays.txt. If I look at hotdays.txt, it looks like the log retained its format, and it looks like there's 26 of them based on my count. And then we'd have to go through weather data and kind of validate that there are, in fact, 26 of them. There's 200 lines here, so I'm going to say there are 26 of them. For your assignment, you might want to find a command line way or a secondary way to validate just to make sure you're getting the correct output. for your error logs, because there are quite a few lines in there as well. But all right, so that should cover everything, right? Pretty simple program, nothing as advanced or long as we've done in previous work. But the key takeaway here is to try to start grasping and understanding the way that generators work and how they're a little bit deceptive, right? If we call a function and assign the value to a variable, we're used to seeing like if this was return, then this variable would have the value that's returned. But since we're using yield, it turns into a generator, and these just become, think about them as prepped objects, ready to do work, but they're waiting until whatever this variable itself needs to be called. And then it will do work one at a time, one yield at a time. It'll never do all the work in one run. All right. Hopefully that makes sense. For your main assignment, all of these concepts are asked, you're asked to perform them in your assignment, and they're all covered here. So you should be able to kind of take this and modify it to work with your individual assignment. It'll be pretty similar there. And I recommend you do a little bit of digging around as well. Do something like I did and try to print the values of these functions or try to print the values of your generator variables before you're calling work on them to try to visually see what's taking place in the code and when the work actually starts getting performed here. All right. Good luck on the assignment, and I will talk with you all soon.